next speaker is Delalic, who is assistant professor at the Faculty of Science and an AI consultant at InfoBip. And he'll talk about smart acceleration of video lectures. Video lectures represent one of the most important sources of knowledge, and there are ways to make it more fast, efficient, and be creative and innovative about that. And our next speaker will gonna talk about it.
I hope you can hear me. Okay. As my colleague already said, my name is Sead. I'm working at the University of Sarajevo, and I will introduce myself a little bit later. But today's topic is basically something that is for wider audience, because each one of us actually we met something, some of those things in reality, and we just consider if there would be some options to accelerate video lectures a little bit smarter. So let's start. First of all, I will give you a short agenda. At the beginning, of course, we will talk a little about motivation behind everything this, and I will show you some researches and some papers that are working on similar subjects, but I must be honest, I didn't find anything which is paper about this topic in this formulation that we will talk about today. We implemented few approaches. We will explain it. After that, I will show you some problems with experiments and results, but some good results also. And of course, we will talk about some future work and a conclusion of the topic. So, first of all, I need to introduce myself a little bit more. As I already said, I'm working at the University of Sarajevo, where I gained my PhD in AI optimization, data mining, and few similar subjects, where my PhD was about using data in solving different problems in combination with meta-heuristics, some other algorithms, and in real-world approaches. Currently, I'm working as an assistant professor at the Faculty of Science at the Department of Mathematics at the University of Sarajevo. But I have, well, now it's around 7 years of experience in AI industry, where I'm working as an AI consultant for a few companies. And in last 2 years, I'm working with InfoBip on solving their AI problems. Okay. So, as we already know, in today's world, we have a lot of online platforms, and each one of those is collecting a lot of data. Basically, everything we clicked on, everything we watched, everything, each movement they actually are using that to track all those happenings. And big part of those are video platforms, because in today's world, we just like to watch videos. We are using them to inform ourselves about basically each subject. And those video platforms are mostly some large platforms with a lot of data, but with a lot of interactions between users and the platform. So let's see how can we use those to solve one problem. So as I already said, we have a large amounts of data, and let's see what can we do with those. Video lectures are part of those video platforms. At least in my case, when I want to learn something about some subject, then I mostly consult video platforms, for example, YouTube or some other educational platforms, just to get the first overview of the subject, and then later I will try to research more into the papers and so on. Why am I later not using also video platforms? Because there are some things that are just repetitive. So if you know the basics of the subject, then you will just, in few other videos, you will see the same thing. They are just repeating themselves. So if you are learning about, for example, convolutional neural networks, then you will learn intro to neural networks, and then next video, it's also intro to neural networks and so on. So it's just not something continuous. And when you are reading a paper or something like that, book, then you can just focus on things that are much easier for us to follow. And online platforms for learning were actually mostly popular because open online courses, and many of those basically are there now. And as least as I know, and because I collected some data, all of those platforms are actually collecting many interactions and events from the users while watching those videos. So these are just few of those platforms like edX, TED, Khan Academy, YouTube, Udacity, Coursera, and so on. And they are extremely popular. They have over 10 millions of users per day and so on. So just almost each one of those. And some of researchers from those platforms actually conducted some research that are really helpful and that will use me as a motivation for this problem I will describe now. Okay. So few remarks, and these are basically published in papers. Students watch videos in short segments. So none of us have time and none of us actually want to watch a video of 45 or 60 minutes about something. We are always skipping, we are always accelerating videos, we are just doing something else and so on. So if video lectures are recorded in shorter segments, then of course users will be more engaged in those videos. And of course, attention span is just decreasing rapidly during the video. And of course, if video is longer, then we will see some interesting graphs later. And as I already mentioned, there is a huge problem with repetitive content because if you know something about the topic, then you just don't want to hear the whole introduction again. You don't want to always listening at the same things. You just want to focus on something that is new to you. Okay. And there is one, of course, interesting things, but it's also something that we already know. On edX platform, they actually did a research on few millions of viewers. And they got results that engagement actually correlates with better performance. So if you need to be engaged to follow some lecture, if someone is asking you questions, I will not do that. But if you are writing some notes, if you are answering a quiz at the end or during the quiz and so during the lecture and so on, then you are engaged much more and you will just learn more about that. Okay, so these are some facts that we will, of course, use later. This is one of the most important researches. Basically, one guy, Guo, he's from MIT, and he actually was doing a lot of researches on this topic of, for example, mock videos and what to do with them and some video analytics. And he actually got the conclusion that all video lectures should be limited to 6 minutes. Why is that? Because that's the ideal time where people are just able to follow the video and they are just not losing the attention. So I'm way over that right now. But they are just engaging. They are just there. They know what they are talking about. They are listening. They are still there. They are not on their phones and so on. And it's hard to talk a lot of things in 6 minutes, but okay, so that's the ideal goal. And of course, if the video lecture is shorter, if you are not talking a lot of stuff that is not related to the topic and so on, then the video will actually be more engaging to those students. So as I already said, this was conducted on millions of viewers from edX platform, so it's not something that is, I mean, it is something that we expect, but it's just, I mean, it's like that, so we know that. And how do we solve the problem of those video lectures that are longer than 6 minutes, that are boring, that has repetitive stuff and so on? We have few ideas. Basically, all of us are doing that. What are the ideas? We have something which is linear acceleration. So basically, that's playback rate at the corner, and it's up to 2 times. So basically, if you have 12 minutes of video, then the most you can watch is you can watch it in 6 minutes, unless you are skipping. So basically, those are two models that we are using to watch videos much faster and to gain those information that we think are important for us. And there is a question that's just raising from this, can we do anything smarter? Okay, so we know that we want to watch video lectures in shorter time. We don't want they just to be boring. And is there anything smarter? Is there anything that's data, AI, algorithms, and so on can help us to achieve videos that are much more interesting and so on? Of course, there is editing part where just guys, I mean, folks that are recording videos can edit it to even accelerate it to remove those boring parts and so on. But that's really too much of the work, and they just don't want to do that all the time. So those algorithms that we are talking about right now can actually help to solve that problem also. Okay, so the idea is to accelerate video lectures non-linearly. So in linear acceleration, each part of the video is accelerated, for example, 2 times. And it's not important if that part is important, it is boring, it is something where he's adjusting his mic or something like that. It's just linear accelerated 2 times, and that's basically really hard to follow. I mean, I hope you all try that. It's hard to follow if you don't know about the topic, but if you are already familiar, then it's okay, so you can follow that lecture. But if you are trying to learn something, we will show some results from the experiments, but well, spoiler alert, it's hard and it's basically impossible to follow those videos at 2 times. So how to create something that's called smart acceleration of video lectures? We implemented few approaches. Basically, this was part of my master and PhD thesis, and we are just working on this research for a few years. And trying to implement few things, but I will also tell you about some problems that we are having with experiments. Okay, so first idea is just to remove silence. So if you are having a video lecture, basically that's someone who is speaking to you, and if you are removing those silence in between 2 words and so on, then you will have a shorter video and you will not lose any content, am I right? I mean, it's just something that we expect. So first approach is something that is basically really simple to implement. So we are just removing silence during audio playback. So we are ignoring image part of the video, and we are just working on audio. We are basically eliminating pauses in speech. So how is that working? We detect each part where a person is not speaking. After that, we are removing those matching frames from a video. Basically, we are not even using here some advanced algorithm for speech detection and so on. It's just if there is something or there is no audio basically at all. So it's silence or it's not silence. Why is that? Because sometimes we have videos where audio is not only the speech. So for example, if you are teaching music and so on, that it's not that smart to remove everything that is music basically from the video. So this is a waveform, these are corresponding frames. We have that threshold in audio, and we are just finding all frames where each part of the corresponding audio is not above that threshold, and we are just removing that part. And the results are basically not something that we are surprised of. Basically, videos are shortened up to 40%. So there are a lot of pauses basically in speech, but how is that influencing results? Resulting video is much harder to follow. Why? Well, I mean, it's so obvious. All pauses are there for a reason. So you are not making a pause just to get some breath and so on. It's just you are making a pause to conclude something, to highlight something, and so on. So just to be more interesting. And I listened to a few of those videos with silence removal, and it's just really, really hard to follow. But we have audio that is shorter. So that's one step forward to backwards, but we'll see what else can we do on that topic. Basically, now we are coming to data. As I already mentioned, all video platforms are collecting basically everything. They know what we are clicking on and so on. And basically, idea is to analyze viewing history-based acceleration. So how can we use viewing history to accelerate video smarter? Basically, all platforms has those. What's the idea? Idea is that at each moment, we have data of how many users are watching that moment, how many of users are engaging with that moment. And that's the all data that we need for this approach. So we don't have any privacy data or anything else. And it's just really not that resource exhaustive because you already have all those data on those platforms. But from this paper, we have a few issues and observations with this approach. So let's see a few of those. Basically, this is something from YouTube Analytics. This is data that we got from one professor from Croatia, Toni Milun. I hope some of you are familiar with him. So basically, I reached to him a few years ago and trying to get math videos with hundreds of thousands of viewers. So Toni is the right address for that. He gave me all that data, and I used it for this research. So basically, I collected all YouTube analytics that he has. That is nothing personal to all viewers and so on. So it's just some aggregated data. And this is the view about, this is basically the graph of views at each moment of a video about, I'm not sure, it's something from analysis. So what's happening there? That paper I mentioned before stated that this is happening. 55% of viewers do not watch the video to the end. So basically, this is not from Toni Milun's videos. This is also from edX platforms with millions of viewers from videos. So basically, we are not watching videos till the end. And it's not that only that is important. Is that 36% of viewers are actually abandoning the video in first 3 seconds. So we are just not giving it a chance at all. Maybe sometimes it's a mistake, or you just see someone and you know he will be boring and so on, so you just go to next video. And basically, that research and that data below just doesn't have anything in common. I mean, they are just for 2 independent sources, and you can see that they are just, that's the stat. But there is something really important for me and for this research. As you can see, there are those little peaks and gaps over there. Am I right? So there are some researches about those, and those are something that's called meaningful peaks. There are many researches about that. For example, one researcher stated that there are 6 ways of getting those peaks during the video. It's new slide, it's new theme, it's something that's really important, so people are returning to that part. And there are a few more. There is one in step-by-step videos, so it's new step in step-by-step videos, and a few more, but they are always something that's meaningful. Something is happening there, is something that's really important for the viewers. So what's our idea? Our idea is to try to estimate the curve. This is not that easy because some standard regressions are not working well with this because I mean, okay, this curve is okay, but if you are fitting it with something that's not customized to video data, then it's not that easy to implement it. So I tried some different polynomial and so on, different regressions, but none of them gave me really good results in this topic. For example, I implemented something based on meta-heuristic for curve fitting, where I used few algorithms, BAT, elephant herding optimization, particle swarm optimization, and one one other, I'm not sure right now. I'm using those to find best coefficients to fit the objective function that is that's just trying to find those meaningful peaks. So it's just not trying to fit the curve best. It's their idea is to find the best line to the best curve to expose those peaks. After that, as you can see here in these two bounding boxes, basically it's not that unobvious what's important in this video. Am I right? So if you are following the curve, then you can see that, maybe I have a laser, but it's fine. This part or this part is maybe, or I guess it will be much more important than this part. So what will I do in that case? I will use those peaks and everything that's near that, near those, some parts around, and I will use those to accelerate the video less, because that's something important. And those parts that are below the line, then I will use them to skip them completely or to accelerate them even more than 2 times. Basically that was the main idea. There are many things here that are also happening, but that's the main idea of this approach. So let's see what problem do I have here. This is really not that hard to implement. The hardest part actually is to test those algorithms. Because how can I say that something is better than some other things? What happened there? We created one online platform for experiments. As I already said, I'm working at the faculty. Before I was working as an assistant and so on. I was working with students on some other lectures, and well, actually, we conducted experiments with hundred of them. We had 100 participants, and what were they doing? They were watching 4 video types. So basically, we have the original video. We have a video that is accelerated 2 times. And then we have those 2 other videos, one with silence removal and one with viewing history-based acceleration, which is called HB here. Okay. And for one user, that experiment is around an hour and a half, because they had to watch few videos and so on. So as you can see, this is part of the video that I was showing you before with that curve. And there are some other things, for example, something from statistics, something from psychology, something about Git and so on. So those are only introductory course, but I was paying attention that none of the users know anything basically about those. So they were students from at the end of the high school or beginning of the faculty. And what happens there? So what were the results? Initial results shows that original video is performing significantly better statistically. So at the end of the video, they just couldn't skip anything. They just couldn't accelerate anything. We tortured them a lot. And at the end, they got few questions about the video, and they answered them. After that, some objective people rate those questions with not knowing to which video they were belonging and so on. And what happened there, original video performs significantly better. So no matter what you do, at least we don't know what to do, to have the same results. So if you are watching the video at the original speed rate, that's the best way for you, and just we recommend that definitely. Linear accelerated video is the worst. So if you are watching video 2 times faster, it's just not good. Your grades were just disasters. So don't do that. Okay, even only when you know about the topic a lot and you are just trying to catch few things, that's okay. But if you are trying to learn something, then accelerating video linear is not the way to go. But we got one interesting result is that that history-based acceleration got actually significantly better results statistically than linear acceleration. So this is not one important, I mean, it's not hard to implement algorithm, not that hard to implement. It's not hard to integrate it to some platforms and so on, but it's better than linear acceleration. So of course, we are still working on this subject, and we are trying to improve those algorithms, but the initial results are just fine. So there is something in that subject. And few new ideas. We have many ideas, and we don't have much people to work on them, so we are working slowly. One idea is to use OpenAI models, but not ChatGPT. I really have some problems with ChatGPT. It's so boring. Everybody is talking about that. It's cool, but everybody is talking about that. So I know it can be used for this topic, so I put not only ChatGPT. There is another OpenAI model that can be used for this. It's really open sourced. It can be used to translate speech to text. It's called Whisper. I don't know if any of you heard of it. I heard about it on the last DSC conference in Belgrade, so thank you, Tomislav, if you are here. And what's the idea here? Idea is basically to use Whisper to get transcripts of audio. It's something that each one of us can do, so you don't have to build your own model or anything else. We tested it in InfoBip for some different languages. So, for example, it's working well on Indian market in England, in USA, and so on. It's even working good for Vucic talking Chinese. So it's really, really a good model. So it's working well. And idea is basically to use some other tools to find keywords in that video. To use those transcriptions to find just what's meaningful in that, to find key sentences and so on. There are many methods for that, and the important part for that is that Whisper is returning basically a timestamp for each transcription. So you know where something was said, and that just can be used, I mean, for getting better results. And of course, that's what I was talking about. And if you have the complete platform, then you can use some other ideas. So this is something that's just platform independent. You have data, and you can analyze it and implement it as part of the one JavaScript or HTML file. But what really bothers me that there is no one tracking user knowledge. So if you are watching many videos, then you learn some stuff before. And then it's important for the platforms to track those knowledge and just maybe to create clusters of users to see in video acceleration where those clusters can be used. So if, I don't know, some of Nino, am I right? Great lecture yesterday. So if Nino and I have similar interests, then what's the idea? Basically, if you are watching a new video and Nino already watched that, then I can use those data to find where he was skipping, where he was accelerating video and so on, and that can just improve my viewing experience. And of course, that's the idea. So if I know something, just remove that. And of course, if you are using Whisper or something like that, then it can be just implemented really, really easy. As I already said, this is relatively unexplored topic because you have something which is video summarying, where you are trying to find a few key minutes of a 1 hour video, or you have a football match, you are trying to find all goals and so on. So that's something that's kind of different. I mean, it's similar, but it's not the same problem because you are you have much more place to be wrong, but much more data to explore in these types of video acceleration. And of course, this can be implemented not only on video lectures, but it can be implemented for some different types of videos. But we used only this subject. So thank you. I'm ready if you have any questions. There's one question.
Thank you very much. One question to your trials with Whisper. Is there any way you explored that you can segment a talk into various stages, like with salutation is the most obvious thing or conclusion, but where you can also qualify, okay, now the speaker goes into the details, now he is more in a phase where he prepares it. Is there some exploration on that?
Yeah, well, I didn't do that on this lecture on this topic, but we had a hackathon a few months ago in a company, and basically we explored something of a summary of video calls. So basically that's the idea, just to find few key points, or I don't know, as many key points as you want, and to use those to find those interesting things where he was talking in details and so on. And there are much more models there that are working really well, not only ChatGPT or something like that. But what's important in this research is just not to use too much power. So for example, if you want to use Whisper, then you cannot do it on CPU. You need to have a dedicated GPU to translate, to transcript video and so on. It's one-time job, but if you are using some other models, then it just cannot be implemented on some edge devices and so on. So my approach is something that you can use on basically anywhere. So that's one great place.
This is working, yeah. So thank you for the lecture.
Thank you.
What would happen if you would slow down the video? Did you think about it, test it? Would that improve comprehension in some cases?
Yeah, we actually tried that, but I mean, those experiments are really time-consuming and sometimes expensive, so we didn't experiment on many people, but, oh, that sounds wrong. Okay, so what was happening that if you are slowing down the speech, then it's not working well. So it's just the same thing as when you are accelerating it too much. It just irritates people. So we try to find those examples, but as you can see, it's really, really boring, so it's just not working well. But that was one idea that I actually tried, so it was not working well. Yeah.
Thanks.
But sorry, there is something that you can make that part louder. That was something that was working. So if something is really important, then you can just make a speaker louder. And that was showing some good results. So many ideas. Oh, great.
What happens if you're using history-based accelerates with new videos? Do you have to use some other technique until it gets a sufficient sample, or how do you handle that?
Yeah, that's the problem. In those videos that we used in experiment, we have some of them had, for example, 100 of views, and some of them has few 100,000. So there are good results even of those with few hundred of views. So you just have to torture few people to watch it. But after that, it's just working well. And even that, we have some other techniques to make that line that we got from video platform even. Just the idea is to find those peaks, and those peaks are actually happening if you have few dozens of views. So if all of you watch some video, then I will find the most important parts just like that. It's really working well on few dozens of you. It's working well. I already tested that.
Hi, Sad. Did you or someone else explore the way of more trying to give advice to the content creators? So basically summarizing the video that they made and telling them, okay, this part is not really that interesting or productive, so you could skip that at all, and maybe not serving that as an accelerated.
Yeah, that's something that can be done if you have a platform. So basically, we don't have that yet, maybe in the future, but it's not that easy to do that. But there are some researchers where I watched, and they were using some ideas like that. I mean, it's not that, but it's something like history-based videos and so on, to find, to advise those content creators to what to do. So for example, if they are creating too long videos, then they just don't do that. If they have bad lighting, then they just fix that and so on. So there are some researches about that. Even a few years ago, I read about that. Great question. Okay.
Are any of these practices something that you would translate to in-person teaching?
Not yet. We will see. I'm not sure.
So you don't see like the opportunity for, say, teachers to maybe, slow down,
Yeah.
essentially be guided by your analytics about how to teach?
It can be done during that process of creation videos, or if you have a lot of videos from Tony Milun, then you can give him some advices. But if you are, that's just a lot more job. For example, you have to know which lecturer is talking about something. There are some, for example, I'm great at one subject and I'm disaster at some others. So sometimes it's just hard to collect all those data that can be used to get all those things. So, for example, if you have a video platform with a lot of videos, then you can implement many of those things. I think it can be implemented basically easily, but it's also a good idea, but I think it's hard if you don't have a lot of data. Okay, so thank you.
Thank you.